my channel. I am Dhanitya Verma, pursuing Integrated MCA at IPC Indo. In this video, we are going to discuss about how the BNS sections would be applied. So let's start. This video will explore the application of knowledge discovery and databases (KDD) to identify relevant section of the Bharatiya Nyaya Sanhita for given complaint. By analyzing a real-world case study, we will demonstrate the process, benefit, and potential of KDT in legal applications. Step 1. Data collections. Gather relevant data. First, we will gather all the relevant data about the complaint. This might include detail about the incident, the victim, the accused, and any witnesses. Second, structured and unstructured sources. This data came from various sources such as police report, witness statement, medical record, and even social media posts. Third, ensuring data integrity. It is crucial to ensure that the data collected is accurate and complete. Errors or inconsistencies can lead to flawed results and misinterpretation. Step 2. Data preprocessing. Data cleaning involves removing irrelevant data, fixing inconsistency, and handling missing values. Second, data transformation. We will need to convert data into format that is suitable for analysis, such as encoding categories, variable, or normalizing the numerical data. Third, feature engineering. This involves creating new features from existing data, accuracy, and effectiveness of the analysis. Step 3. Data transformation. First, data normalization. This process ensures all the data is on comparable scale, preventing certain features from dominating others during the analysis. Data reduction. By eliminating redundant or irrelevant data, we can improve the efficiency and speed of the analysis while maintaining accuracy. Data discretion. This involves grouping continuous data into discrete categories. Step 4. Data mining. First, we will do pattern recognition. We will use algorithm to identify pattern and relationship within the transformed data. Clustering. This technique groups similar cases together, highlighting common theme and identifying distinct patterns in the data. Classification. Algorithms are employed to predict the outcome of a case based on its characteristics pattern. Now, by applying KDD to complaint, first collect data. Detail about the incident, the victim, accused, and any witnesses. Prepare pre-processed data. Clean, transform, and engineer feature to prepare for analysis. Third, mine data. Identify patterns and relationships using various algorithms like clustering, classification, etc. Now we will see how to identify relevant BNS sections. First, pattern matching. Match identified pattern in the data to relevant section of the BNS, like theft or assault. Second, legal expert reviews. An expert lawyer should review the result, ensuring accuracy and alignment with the legal principles. Third, final recommendation. The identified BNS section can be used to guide legal proceeding and ensure appropriate justice. Useful algorithm in the process. While the specific algorithm and code vary depending upon the data and the BNS section be identified, some common approaches include first, text mining algorithm. These are analyze text data such as natural language processing techniques to extract key concepts and identify relevant terms. Second, classification algorithm like support vector machine SVMs or decision tree to predict the applicable BNS section based on the characteristics of the content. Rule-based system that use predefined rules based on the BNS section to identify the relevant clause based upon the fact of the case. Decision tree analysis in the data science. Decision tree analysis is a powerful tool in data science used to classify and make predictions. This presentation will explore more building and applying decision tree for effective complete classification. Decision tree algorithm. First, decision rule. Decision tree use a series of if-then rules to classify data. These rules are based on values of various features in dataset. Tree structure. A tree structure consists of nodes, branch, and leaves. Each node represents a decision point, branch represents possible outcomes, and leaf represents the final classification. Data preprocessing. Decision data are trained and dataset using algorithms like ID3, C4.40, or CART, which learn the optimal rule to best classify the data. Steps in construction of a decision tree. First, data preparation. Prepare the dataset by cleaning and transforming the data into suitable format. Second, feature selection. Identify the most relevant features that contribute to classification of complaints. Third, tree construction. Build the tree using an algorithm, recursively splitting the data into smaller subsets based on the selected feature. Fourth, tree pruning. Optimize the tree to avoid overfitting. Applying decision tree for complaint classification. First, complaint data. Gather the data set of the customer complaint with various attributes such as product, issue, severity, and resolution. Feature engineering. Engineer feature from a complaint type such as keyword, sentiment, topic, or modeling to enrich the data for the classification. Tree training. Train a decision tree model on the complaint data to learn the pattern and relationship between feature and complaint categories. Prediction. Use the trained model to classify new complaint. Now we will map complaint to IPC or BNS section. First, rule-based map. Decision tree provides a set of rules that can be used to map complaint to appropriate IPC BNS section. Automated classification. This mapping can be automated using a trained decision tree model, enabling efficient and consistent complaint routing. Transparency and auditability. The rules generated by decision tree provide transparency and auditability, allowing for clear understanding of the classification process. Best practice and challenges in decision tree implementation. First, data quality. Ensure clean, accurate, and relevant data for training and validation for the decision tree model. Second, feature engineering. Develop effective features that accurately represent the content and context of the complaint from improved classification. Model evaluation. Evaluate the performance of the decision tree using metrics such as accuracy, precision, recall, and F1 score. Text mining performance metrics. Text mining is the process of extracting meaningful information from unstructured data. Evaluating the performance of this algorithm requires a set of metrics. This presentation will explore various metrics used to access text mining tools. Effectiveness of metrics. Evaluating model performance. First, precision. Precision measure all the proportion of the relevant document correctly identifying by the model. Precision is the number of correct positive prediction divided by total number of positive prediction. Recall. Recall measures all the proportion of the relevant document that are very correctly identified by the model. Recall is the number of correct positive prediction divided by total number of actual positive cases. FN score. FN score means harmonic mean of precision and recall, offering a balanced measure of a model's performance. Accuracy matrix. Confusion matrix. A table that summarizes the performance of a classification model, highlighting correct and incorrect prediction of each class. Accuracy. Proportion of correctly classified instance. Accuracy is calculated by dividing number of correct prediction by the total number of instances. Specificity. Proportion of correctly classified negative instances. Specificity is calculated by dividing number of true negative by the total number of actual negatives. Sensitivity. Proportion of correctly classified positive instance. Advanced matrices. First, preflexity. Second, coherence. Third, lift. In this video, we have discussed how we can generate an applicable IPC section that can be applied over a complaint. Thank you for being with me. If you like the video, please hit the like button, please do comment and subscribe my channel. Thank you.